Jai Hind everyone. Today we are going to have a lecture on operators in C language. This is covered in KCA 102 problem solving in C and it is basically for MCA students. I am Shruti Jain, assistant professor from the MCA department, Ajay Kumar Garg Engineering College, Ghaziabad. So when we are talking about any of the programming language, we have some of the operators that are to be used in the language so that while we are doing the programming, so that the calculation becomes easy and it is we are able to perform different operations in any of the in the programs that we are doing. So coming to what basically an operator is a symbol that specifies the mathematical, logical or relational operations to be performed. So we have three types of operations that are to be performed. The first one is mathematical, that is arithmetic operations. Logical, that talks about the logic in the program, and relation, that talks about the relation between the two variables that are being used in the program. The C language supports different types of operators which can be used with the variables and constants to form an expression. So we have two types of, we have the variables and the constants which are used along with the operators to define an expression. So these operators are used to establish the relation or a logic or the different operations, arithmetic operations between two variables or constants or a mixture of both. So the next one that we have is the types of operators. The first type of operator is arithmetic operator, then relational, logical, unary operators, conditional operators, bitwise operators, assignment operator and comma operator. The last one is the size of operator. So when we talk about the arithmetic operators, the type of operators that we have is plus, minus, multiply, divide, modulus and division. So this modulus operator returns the remainder and this division operator returns the quotient. When we talk about the relational operators, these relational operators are like less than, equal to, greater than, equal to, not equal to and so on. That means they define the relationship between any two operators. The logical operators, we have the logical and, logical or and not operator. Unary operators are those operators that need only one operand to work upon. For unary operators, we have the increment operators, the decrement operators, the unary plus and the unary minus. The conditional operators that we are talking about are the ternary operators which need three operands to work upon. This is a conditional operator which can be used in place of a normal if-else statement. The bitwise operator, we again have the bitwise and, bitwise or, bitwise not, and we have the left shift operators, the right shift operators and so on. The assignment operator is the equal to sign which assigns the value from the right hand side to the left hand side. The comma operator is a separator which separates the different values, and the last one is a size of operator which talks about the size of the variable that we have. Size of the variable or any of the data type, it returns the size of that particular data type or the variable of a particular data type. So this we have the arithmetic operators, relational operators, logical operators, unary operators, conditional, bitwise operators, assignment operator, comma operator and finally the size of operator. So coming to the arithmetic operators, the first one is the multiplication, which the syntax of writing it is A multiplied by B. So if we have the value of A as 9 and the value of B as 3, then 9 multiplied by 3 will give us 27. Divide returns the quotient. So when 9 divided by 3 is given, that is 3, that is the quotient when we divide 9 and 3. So we get 3 3s are 9 and the remainder is 0. So this is being returned when we have A divided by B, and when we have A modulus B, the remainder is returned over here. A plus B is a simple addition to be performed between 9 and 3, and A minus B is 9 minus 3 as 6. The next one that we have is the difference between the divide and the modulus operator that we just checked. So when we have A equals to minus 10 and B equals to 3, the division, the quotient that is returned is minus 3 and the remainder that is returned is minus 1. Now when we have the value of A as positive and the value of B as negative, in that case A divided by B would be minus 3 only, but the remainder becomes 1. Now why does the remainder change over here? Whenever we are dividing minus 10 and 3, the modulus operator always takes the sign of the first value. So if the dividend over here is negative, the remainder would be negative. In the second case, we had the dividend as positive and the divisor as negative. In that case, again the dividend was positive, that is why the remainder was positive over here. So whenever we have the dividend as positive, the sign of the dividend decides the sign of the remainder. The quotient remains the same. Now coming to the relational operators, the relational operators as we have seen were less than, greater than, less than equal to, greater than equal to or not equal to. So less than operator, it checks whether 3 is less than 5. If the condition is true, if 3 is less than 5, it returns true. The value of true means 1, and if the condition is false, the relation that is shown over here is false, then it will return the value as 0. So in the next case, if we check that 7 greater than 9 is false, that is why it returns the value as 0, because it is false. 100 is less than equal to 100, that is true, so it returns 1. 50 greater than equal to 100 is false, that is why it is returning 0. 20, this is a comparison operator, the equal to sign. So whenever we are writing A equal to B, in that case this equal to sign compares this LHS with the RHS, the L value with the R value. It checks whether A is equal to B or not. If A is equal to B, in that case it returns a value as true. If A is not equal to B, in that case it will return the value as false. The not equal to 20, not equal to 20, that is false, that is why it returns a value as 0 over here. The next type of operators that we have are the logical operators. The logical operators are the logical and, logical not, the logical or. Now what does logical and say? Suppose we have two variables A and B. So we have the logical and the logical or, that is to be discussed over here. Now the normal conditions or the normal combinations between A and B could be, A could be true, true, A could be false, B could be true, A could be true, B could be false, or both of them could be true. Or both of them could be false. So A and B says, if both the conditions are true, only then A and B would give the result as true. If any one of the condition is false, the result would be false. So here it says 6 greater than 5 is true, 7 greater than 9 is false. True and false gives the result as false, that is why the result is 0 over here. So the logical and means whenever both the variables or both the conditions between which we are adding this logical and, when both the conditions are true, only then the result would be true, otherwise the result would be false in all the cases. Now when it comes to the logical or says, if any one of the condition is true, the result would be true. The result would be false only when both the conditions would be false. So when we are talking about logical and, the logical and says only both, it would be true only when both the conditions would be true, but logical OR says if any one of the condition is true, the result would be true. It would be false only when both the conditions would be false. 6 greater than 5 is true, 7 greater than 9 is false. So true or false will return the value as true, or false return the value as true. That is why the result would be 1. The logical NOT is just a negation. If the value of A is true, the NOT of A would be false. If the value of A is false, the NOT of A would be true. So it just negates the value. So 6 greater than 5 is true. So NOT of true would be false. So the result over here would be 0. 6 greater than 5 is true. So NOT of true would be false. So the result over here would be false. So in the note, as we have discussed, it says if the first operand is is false in case of logical AND, then second operator will not be evaluated. That means if we get the first operand, here we get the value as false, then there is no use to check the second operand, because if any one of the condition is false, the result would be false in the logical AND. Similarly, if the first operand is true in case of logical OR, then the second operand will not be evaluated, because logical OR says if any one of the condition is true, the result would be true. The next type of operators that we have are the increment-decrement operators, which are the unary operators. So the increment operator, this increment operator, what does it do? It could be either pre-increment operator or it could be a post-increment operator. When we are putting the operator before the variable, that is pre-increment, and when we are adding the operator at the end, that becomes the post-increment. So what does it do? Whenever we have the value of A, suppose we have the value of A as 6. So A plus plus would increase the value of 6, but what happens? What is the difference between plus plus A and A plus plus? Suppose in the memory I have the value of A as 5, or maybe the value of A as 6, plus plus A would increase the value and then it will store. So plus plus A would be 6 over here, and in the memory also it would be 6. But A plus plus would keep the value of A as 6 here, and later on it will increase in the memory. So if you are currently using the value of A and you are using the A plus plus, it will first use the value and then increment in the memory. So that is the difference. Plus plus A would increase the value and then use. A plus plus will use the current value and then it will increment it. So if you look over here, B equals to A plus plus, it will first assign the value. That means this value of A will be assigned to the variable B. So B remains 6 and then increment the value in the memory. So when the memory is incremented, the value of A becomes 7. But if we look at the example over here, in plus plus A, it will increment and then store. So it will first increment the value, then assign the value. So when it increments the value of B becomes 7. This B becomes 7 and A, because it was incremented, it again became 7. The same difference appears when we are having the decrement operator, the pre-increment and the pre-decrement and the post-decrement. So pre-decrement will again, it will decrease the value and then use, whereas the post-decrement would be using the value first and then decrementing it in the memory. The next one that we have is the assignment operator. The assignment operator just assign this value to the variable that is available on the left side. So this 6 is basically the R value that we are talking about, and this A is the L value that we are talking about. So the assignment operator always assigns the R value to the L value, the value that is there on the right hand side or the expression that is there on the right hand side is evaluated and the value of it will be stored on the left hand side. Here A equal to 6, A is called the L value. The L value should always be a variable and 6 is a R value which can be a variable, constant or a constant expression. So it could be anything. Whatever expression we are getting, if we are evaluating that expression, the value of it will be stored in the L value which will be a variable. The next comes are the bitwise operators. The bitwise operators are the bitwise AND or XOR, bitwise left shift, right shift and the ones complement. So coming to the bitwise AND operator, the bitwise AND operator is used whenever we are converting both the decimal numbers. If we are talking about 5 and 6, this 5 and 6 are the numbers in the decimal form. So what we do, we first convert these decimal numbers into the binary representation. So if we look here in the example, the binary representation of 5 is basically 0101, but if we are looking it into the 16-bit form, it becomes like this. The binary representation of 6 is again 110, and because we are working on the 16-bit form, so it is embedded with all the zeros or it is prefixed with all the zeros over here. Now when we are using the bitwise AND, it is same as that of the previous one. If any one of the value is false, the result would be false. So 1 represents true, 0 represents false. 1 and 0 will give us 0 because true and false gives us false. 0 and 1 again 0, 1 and 1 will return 1. So the binary representation of this 100 is 4. Therefore, when this is again converted to the decimal representation, we get the answer for 5 and 6 as 4. The next is bitwise OR. Again, this 5 and 6 are when used with the bitwise OR. The bitwise OR says if any one of the value is true, the result would be true. So here again the 1 represents true and 0 represents false. 1 or 0 will return 1. 0 or 1 would return 1. 1 or 1 would return 1. This 111 is the binary representation for the decimal number 7. That is why the result of 5 or 6 is 7. The next that we have is bitwise XOR. The bitwise XOR says when we have the opposite numbers, the result would be 1, and when we have the same numbers, like when both the values are true, we'll get the value as false. When both the values are false, like when we have A and B, they both are true, they both could be false. One could be true, one could be false. So when we have the different signs of them, we get the result as 1. When both of them are same, we get the result as 0. So for 5 and 6, 1 and 0 are two different values. So the result is 1. 0, 1 with XOR gives 1, but 1 and 1 would give 0. This 0, 1, 1 is a binary representation of the decimal number 3. That is why 5 XOR 6 gives us the result as 3. The next bitwise operator that we have is bitwise left shift. So if we look here, it says that bitwise left shift by 1. So this binary representation of 5 is 101. We shift them to 1 bit towards the left and we embed an extra 0 towards the right. This 1010 is a binary representation of 10 and hence the result is 10 in the decimal form. The bitwise right shift operator, it will shift the digits towards the right. Hence, this digit would be lost and all the digits will be shifted to the right. At the left side, we will have an extra 0 added. This 0010 is a binary representation for 2 and hence the result is 2. The next that we have is a bitwise complement. So when we are talking about the complement of 6, the binary representation of it is 110, and the 1's complement says that 0 becomes 1 and 1 becomes 0, and hence we get the result as -9 over here. The next operator that we have is a conditional operator. This conditional operator is basically the ternary operator which needs 3 of the expressions to be there. This first expression is a condition to be checked. So if the condition is true, this expression 2 would be executed, and if the condition is false, the expression 3 would be executed. So it says if expression 1 is true, then expression 2 will be evaluated, and if expression 1 is false, then expression 3 will be evaluated. So this is a condition that is to be checked. 12 greater than 6 is true, and in the true we have the result as 1. So the result would be 1. The next type of operator that we have is a size of operator. The size of operator, it evaluates the memory size of a variable. It could be a constant or it could be an expression. So if we look over here, this size of operator is a predefined operator. The int has a memory size of 2 bytes. That is why when we are asking for the size of int, it returns a value as 2. If we look here, this 5 again is an integer value, integer constant, and hence the size of 5 would again be 2. Whenever an expression is entered into the size of operator, it first evaluates that expression. So 5 plus 6 is 11. 11 is an integral value or an integer constant. Again, the size of 11 would be 2 bytes. The comma operator. The comma operator is a separator. What it does is, whenever we are given the values like this, it would be just taking the first value, a equals to 3. And it won't go for any other value because no other variable is mentioned. If suppose we have multiple variables on the left hand side and multiple constants on the right hand side, so the first constant, the first variable will be referring to the first constant, the second variable for the second constant, the third variable for the third constant, and so on. Since here we have just one variable, so it will be taking up the first constant and will discard the rest of the values. But if suppose we have a bracket over here, in that case, this a would first go for 3, then 4 and 5, and finally it will take the value as 5. So it would be traversing all the values and will be taking up the last value. Similarly, if we talk about a equals to b plus equal to a plus plus b, in that case, this a equal to 6, this b plus equal to means b is equal to b plus a. So b plus a, b equals to b plus a. Here we have the value of a as 4 and value of b as 1. So if the value of a is 4 and the value of b as 1, the value of b becomes 5. Plus plus 5 will pre-increment it. That means the value of b becomes 6. It will first solve this and proceed to the next value and will display plus plus b, that is the value of b as 6. Now this value of b as 6 is to be stored in the variable a, and hence the value of a becomes 6. The next that we have is operator precedence and associativity. So what is basically the precedence? It talks about the order of evaluation of different operators when in an expression we have mixed operators given. So precedence of operators determine the order of evaluation when they occur in the same expression, which is called a mixed expression. Associativity of operator determines the order in which operators of equal precedence are evaluated when they occur in the same expression. The associativity defines the direction, that is, it could be either left to right or right to left, in which the operators act upon the operands. So if we look over here, we have the operator precedence. The first one that we talk about is a function call or the square brackets, which are normally used in the arrays. The arrow operators and the dot operator, they are always evaluated from left to right and are at the first precedence level. Once this is being solved, then we have all the unary operators, unary plus, unary minus, increment, decrement, logical not, bitwise operators, address operator, typecasting and size of operators. They are from right to left. The associativity of them is from right to left, and here left to right would mean like this. They are at precedence level 2. Once these all unary operators and the different operators, bitwise operators, are evaluated, the next we have are the arithmetic operators. In the arithmetic operators only, multiplication, division and modulus, they all are at the same level and are evaluated left to right and are at precedence level 3. The next, once the arithmetic operators, multiplication, division and modulus are solved, at the next level 4, we have the addition and subtraction operators, which are again evaluated from left to right. Then at precedence level 5, we have the right and the left shift operators, again in the direction left to right. Once the arithmetic, the bitwise operators, the shift operators are done, then we have the relational operators. The relational operators are again evaluated left to right and are at the precedence level 6. Next comes the equal and the not equal operators at precedence level 7. Then we have the bitwise and, XOR, or, the logical and, or, and at the last we have the conditional operator. And these operators are all evaluated left to right except the conditional operator, which is evaluated right to left. The last, we have all the assignment operators. These are the shorthand operators wherein, as we have just discussed, multiply equal to, if I write it like this, means A equals to A multiplied by B. So these all assignment operators are evaluated right to left and are at the second last precedence level, and the last precedence level we have the comma operator, which is again evaluated left to right and is at the 15th precedence level. So it is not necessary that in an expression we have all the operators, but yes, we have a mixture of operators, and using this table we could it would be easy to identify which operator will be evaluated first and then in which direction if we have multiple operators to be evaluated which are at the same precedence level. Thank you.